हेलो बच्चों, आज D&F ब्लॉक पढ़ेंगे। ओके, तो पीरियोडिक टेबल में हम लोगों ने S ब्लॉक, P ब्लॉक, D ब्लॉक, F ब्लॉक देखे हैं। तो D ब्लॉक एलिमेंट्स कौन से होते हैं? D ब्लॉक एलिमेंट्स को D ब्लॉक एलिमेंट्स क्यों बोला जाता है? डी ब्लॉक एलिमेंट्स वो एलिमेंट्स होते हैं जिसमें लास्ट इलेक्ट्रॉन एंटर्स द डी सबशेल ऑफ पेनल्टीमेट शेल। मीन्स their general electronic configuration will be n-1 d 1 to 10. ns it could be 1 or 2 electron, और यहाँ पर n क्या है? n is the outermost shell. D block element consists of group 3 to 12, right? And it occupies the large middle section of the periodic table. Now the main question is, why do we call them transition elements? So elements of D block are transition elements because they possess properties that are transitional between S and P. S and P block elements. And secondly, transition element is defined as element which has incomplete filled d orbital in its ground state or any one of its oxidation state. So इसका मतलब ये हुआ कि जो हमारा जिंक है उसको हम ट्रांजिशन एलिमेंट की कैटेगरी में नहीं डाल सकते. The reason is that zinc has atomic number 30. It is completely filled 3d10 4s2, and also its oxidation state, most common oxidation state, that is Zn plus 2, that is also filled because electrons are removed from the 4s and it is having 3d10 fully filled d orbital. So according to this definition of transition element, zinc is not considered as transition element, and same way cadmium and mercury also are not in the transition element category. And broadly, transition elements are classified in 4 types. Like first transition series, we call them 3D series also. Second transition series means 4D series. Third transition series means 5D series, and the fourth transition series 6D series. If I talk about first transition series ना, इसमें जो एलिमेंट है वो स्कैंडियम एटॉमिक नंबर 21 से लेके जिंक 30 तक मिलते हैं. सेकेंड ट्रांजिशन सीरीज में यूट्रियम एटॉमिक नंबर 39 टू कैडमियम 48 एटॉमिक नंबर. थर्ड ट्रांजिशन सीरीज जो कि 5D सीरीज है उसमें लेंथेनम टू मर्क्यूरी, उसमें हम सीरियम टू Cu 71 तक हम उसको नहीं काउंट कर रहे हैं. एंड द फोर्थ ट्रांजिशन सीरीज मीन 6D सीरीज, ये एक्टीनियम से स्टार्ट होती है एटॉमिक नंबर 89 एंड इट इज स्टिल इनकम्प्लीट. सो जिंक, कैडमियम एंड मर्क्यूरी of group 12 have fully filled D10 configuration in their ground state as well as in their common oxidation state. So they are not regarded as transition element. It is very important question from the board angle also. So being the end element of 3 transition series, their chemistry is also studied along with the chemistry of the transition elements. Now I am going to start with the general characteristics. Like first characteristic I want to study today is atomic radii. अब बच्चों जब हम atomic radii के बारे में पढ़ेंगे, यहाँ पे कुछ ups and downs तुम लोगों को मिलने वाले हैं, और उसमें मेजर आप लोगों ने 2 चीज़ों में ध्यान रखना है. एक तो न्यूक्लियर चार्ज, राइट, न्यूक्लियस जिस अट्रैक्शन से आउटरमोस्ट ऑर्बिट के इलेक्ट्रॉन्स को अपनी तरफ खींचता है, और दूसरा इसका जो है इसके इलेक्ट्रॉनिक रिपल्शंस वंस द half filled electrons start filling up, means screening effect. So major 2 effects you have to understand. These 2 effects like effective nuclear charge and the screening effect. These two factors are actually responsible for the atomic size. So let us start about it. Like atomic radii of transition elements are smaller than S block and obviously larger than P block. And this is the normal trend, as we understand in periodic table also. When we move from left to right, size decreases. So S block will have higher size, then D block will have smaller, and P block will have further smaller size. But in between the series, there we saw some trends that we are going to do now. In the transition series, the atomic number increases, atomic radii first decreases till the middle and become almost constant, and then increases toward the end of the period. So why this is happening so? बच्चों होता क्या है? The decrease in atomic radii in the beginning is mainly due to increase in effective nuclear charge with the increase in atomic number. लेकिन with the increase in number of electron in n-1d subshell, the screening effect of these electron on the outermost ns electron also increases. And this increased screening effect counterbalance the effect of increased nuclear charge. So, what happens? What will happen? Atomic radii remain almost constant in the middle of the series, and then increase in atomic radii towards the end. This attribute to the electronic repulsions, because in the starting your d orbitals are getting filled up slowly and slowly. Once they are half filled, after that pairing will start happen. एक ऑर्बिटल में दो इलेक्ट्रॉन जाने शुरू हो जाएंगे, पेयरिंग होनी शुरू हो जाएगी, इलेक्ट्रॉन के बीच में लड़ाई शुरू हो जाएगी, मीन्स रिपल्शन शुरू हो जाएंगी, है ना. द पेयरिंग ऑफ इलेक्ट्रॉन इन द डी ऑर्बिटल ऑफ द पेनल्टीमेट शेल अकर ओनली आफ्टर द डी सब शेल इज हाफ फिल्ड. This repulsive interaction between the paired electron in d orbital become very dominant toward the end of the series. और ये इलेक्ट्रॉनिक रिपल्शंस इतनी ज़्यादा हो जाती हैं कि एक्सपेंशन हो जाती है भाई, एक्सपेंशन ऑफ इलेक्ट्रॉन क्लाउड हो जाता है, और जिसकी वजह से एटॉमिक साइज के बीच में आपको काफ़ी अच्छा जो है इंक्रीज देखने को मिलता है. So atomic radii usually increases down the group, but the atomic radii of elements of second and third transition series belonging to a particular group are almost constant, and this is the lanthanoid contraction, which I will tell you later on. Then second part is ionic radii. The ionic radii of transitional elements follow the same order जो मैंने अभी आप लोगों को atomic radii में समझाया. So the decrease with increase in oxidation state, like for example Fe2 plus ferrous, that is 76, and Fe3 plus, that is 64 picometer, state the ionic radii generally decrease with increase in nuclear charge. So this was all about the atomic radii.